by power 6. So 0.02 divided by this, so it's equal to 166.796 times 10 to power of minus 12. Okay, and I just want to write the units is meter per Newton. Okay, so I get 166.796. So now we know we want to find when, okay, we want to find C now. Okay, so we're going to substitute. So we know that the equation now is equal to y is equal to 166.796 times 10 to the power minus 12. Okay, stress x plus by C. Okay, so now we're going to find C, and we're going to use the point. Then we're going to use, it's just method of substitution now. We're going to use 52.732 times 10 to the power 6 and 8.154 times 10 to the power minus 3, because I make everything in meters and in newtons. Okay, so therefore what you have is your y is 8.154 times 10 to the power minus 3. So this is equal to 166.796 times 10 to the power minus 12 stress x. Okay, or stress x, we know that is equal to what? 52.732 times 10 to the power 6 plus by C. Okay, so therefore C is equal to, so 166.796 power minus 12 times by 52.732 power 6. Okay, so 8.154 power minus 3 minus by this, so it's equal to minus, or C is equal to minus 6.416 times 10 to power minus, okay, sorry, so it's 8.154 power minus 3 minus 166.796 power minus 12 times by 52.732 power 6 is equal to 0.641 right, times 10 to the power minus 3 meters. So it's moving downwards. Okay, so if you look at both equation, it's the same. Okay, down here I don't need to remember any formula. Okay, I just, yeah, it's longer, that's for sure, but if you cannot remember the formula, you're a bit of a trouble. Okay, now if this material now is a sandwich material, okay, so now if this is a sandwich material, so for example, this is made of material number 1, this is made of material number 2, right? It's the same thing like what we have done before, right? It's the same thing as like what we have done before over here, right? It's exactly the same. The only difference you do is you have to apply this formula, right? So you know area of 1, area of 2, you know the 2 Young's modulus, you know your P of x, okay? You just substitute them in, okay? So it's just plugging in your formulas in this aspect, okay? Right. Now, the area over here are the true area. You don't compensate, okay? You don't compensate by the n. It's not the same like in bending, okay? So the last topic that I'm going to teach today, the last topic that I hope to finish today, okay, is a topic on centric, and I'm going to write up the formula for you later on. Okay, it's known as centric. No, it's eccentric, not centric. So eccentric. Wait, no, eccentric. Sorry, even I get confused. Okay, I have a question. Sorry. Well, yeah, marks will be deducted if you don't label the coordinates, okay? Because I say label, okay? You have to label them. So I would, if your trend is correct, okay, you get half a mark. If you don't label, if your trend is wrong, you got no marks, okay? Just to let you know. Okay, so we are going to look at centric. Now it's different. Unsymmetrical. Loading. Okay. So now I'm going to put in more formulas. Okay, it's going to be not any more difficult. Okay, still the same. Head of the bending moment, arrow is compression, tail end of the bending moment is tensile. Okay, so how do you identify or I'm going to show you a condition where we have centric unsymmetrical loading. Okay, I'm going to draw to you now. So let's say now we have a structure that look like this. Okay, okay, this is how our structure look. Then if I'm going to draw my transformation, let me push it up a bit. So now we have our transformation. This is our Y. This is our Z. And then I'm going to draw our position of our centroid. Okay. So this is my Y. This is my Z. Okay. Now the moment is going to be applied this way. Okay. So there's our moment. And when you use right hand rule, you look at your thumb, then you point your thumb and you grip. Don't close your hand, okay? Don't close your hand. Just grip like that, okay? Just grip like that, okay? So if your thumb is the head of the arrow, and when you grip, right? Don't do this, okay? You do this, you get confused. It's just how your hand is gripped. This is your moment. Okay, that is your moment. So when that's the case, now your moment has two components. Okay, your moment has mz and your moment has my. Okay, so I'm going to draw the mz. So this is your mz. Okay, so this is your mz in pink, right? And the way I grip it, okay, so this is your mz. And then the next one is our my, right? So when you grip my, you grip this way, all right? My. So when you do this, what happens? Okay, your mz, right? Your mz will now look like this. Okay, your mz. Okay, so this is compression. Over here is what? Tensile. Okay, and then if I were to copy this, okay, and I were to be putting this at the centroid, right? So what you see that this is under compression, that is under tensile. So if now this part sometimes can be confusing. Okay, I have a way to make it, because some students have a problem about gripping. Okay, when you grip the wrong way, you get really confused. I was really confused. not just you. Okay, I was really confused also. Okay, so the best way to do is this. Okay, if you should do this. Okay, if you find confusing, you should do this. Okay, I like to make things simple for students. I think that is good and bad. Okay, so if you are confused, if this is the moment vector, right, your thumb pointing up, and when you grip this way, right? So this is the moment head arrow, this is the moment vector, and then you label this is head of the arrow is compression, and the bottom part is tensile. Okay, right? It's always the same. Okay, always that direction. Okay, so what I'll do is I will copy. Okay, and then I will paste. I wonder, does it? Yeah, I paste as a picture. Okay, right. Then I make it small. Okay, so I will do this again. I'll copy and I will paste. And then what I
Quick
will
question, sir.
wait, I will rotate towards the left. Okay, I just do this. Hold on, let me finish this first. Right. Then I will again copy. And then I'll paste. Then I will rotate again. Okay, now it's pointing downwards. Okay, and then I'll copy. And then I'll paste. And then I'll rotate this way. No, the other way, the other way, undo. Then I'll rotate towards the left. Okay, so I will usually have this. I'll tell students to usually have these arrows ready, or you print on a piece of paper and then you rotate the paper. It's the same thing. So if you look at MX, okay, the vector arrow is coming here. So you look. Oh, I think I messed this up. Oh God, gee, ooh, sorry. Okay, so the head is compression, the tail end is tensile. Okay, even I mess up only by doing it. So when I put this arrow down here, right, I put this, you can see compression, tensile. Okay, when it's going up is compression, tensile. You can see that, right? It's the same. Okay, so what I strongly recommend is get all this arrow ready before your term test. Okay, where's the question?
Oh, it's good now.
Okay, so you're going to tell me that I make a mistake. Am I right?
Yeah.
Yeah, I realized that. Okay, once I draw all this. Okay, so now once you've got all this, you are good to go. Okay, now I'm going to. So this is really helpful. Okay, it even helped me just now, as you can see. So now I'm going to put this aside. I'm going to write out the formula. Okay, I'm going to put this aside. Okay. So this is always helpful to do. I would strongly recommend you all to do this. Okay, so let's look at the formula now. Okay, let's look at the formula. And this is not any more difficult than what you have learned. And I'll tell you why. Okay. So now we have all our stresses that we're going to find is in the X. So it's going to be equal to my over Iyy multiplied by Z minus by mz over Izz multiplied by y. Okay. Now, a key thing to take note is what did I just teach you? Don't worry about the what? About plus or minus. Right? Your plus or minus are taught to you or given to you based on your moment vector already. Already you know what is your tensile compression, you know what is your tensile compression already. Okay, so don't worry about your plus and minus sign. So do not worry about the sign. Okay, do not worry